In this second session of understanding diffusion models, today we will be studying forward diffusion process. But before that, please do watch part 1 where I have explained overview of diffusion models with an interesting example of diffuse TV. So welcome back to Data Fusion Analytics and let's start understanding the forward diffusion process. So we have this image of a dog which is denoted by x0. We would like to corrupt this image over large number of steps t. Now these steps can be either 500 or 1000 or even more, so that it is indistinguishable from standard Gaussian noise. How can we achieve this particular task? We will use of a function called as q, which will add a small amount of Gaussian noise with variance beta t to an image xt-1 to generate new image which is called as xt. This entire diagram showcases the result which we get after applying this function q. This is the overview of forward diffusion process in diffusion models. Now let's see the mathematical part. Mathematically, xt is equals to root of 1 minus beta t into xt minus 1 plus root of beta t into epsilon t minus 1. Here epsilon t minus 1 is standard Gaussian with zero mean and unit variance, whereas beta t is variance. We have to note here few things. The first one is that xt-1 is scaled to ensure variance of output image xt remains constant over time, and root of 1 minus beta t into xt-1 has variance of 1 minus beta t, and the term root of beta t into epsilon t-1 has a variance of beta t. The forward noising process q can also be written as follows. So this is the short form in which we can write the entire forward noising process or forward diffusion process in diffusion models. But one important question: how can we jump straight from an input image x0 to any noise version of the image xt by skipping the t applications of q? Suppose we have an image x0 and we want to reach x100. How can we directly reach 100 by skipping the intermediate images? The solution to this particular problem is something called as the reparameterization trick. Let's assume alpha t equal to 1 minus beta t and alpha bar t is sum of I equal to 1 to t alpha I. Then we can rewrite the following equation which we studied in the previous slide of xt equal to root of 1 minus beta t into xt minus 1 plus root of beta t into epsilon t minus 1. So if we substitute the values of alpha t and alpha bar t, we get this following equation. You all know that we can add two Gaussians to obtain the new forward diffusion process. Using this equation, the final equation, we now have a way to jump from original image x0 to any image, that is x100 or x200 or xt. Here bonus point is that we can also schedule different diffusion schedules using alpha t bar values instead of original beta t. Now these diffusion schedules we will be studying in the next session. The entire forward diffusion process can be summarized using this one equation. So to summarize everything that we have learned till now, we add a Gaussian noise in a stepwise manner to the original input image, which is called as the forward diffusion process. Hence this is also called as a noising process as well. We have this particular equation which represents the entire forward diffusion process, and we also have a way to jump from original image x0 to any step of the forward diffusion process xt. That's it guys for today's session on forward diffusion process. In the next session of diffusion models mini course, we will learn about diffusion schedules, reverse diffusion process, as well as end-to-end implementation of diffusion models. Till that, like this video, subscribe to the channel of Data Fusion Analytics, comment on this video for your feedback. Bye bye and take care guys.